Welcome to today's class. In today's class, we'll still continue from where we stopped on Hooke's law. So, let's consider the question on the board. It says a stone of mass 5 grams is projected with a rubber catapult. If the catapult is stretched through a distance of 7 centimeters by an average force of 70 Newton, question says calculate the instantaneous velocity of the stone when released. Okay, so let's get down the parameters that was given to us. We have that a stone of mass. So mass was given as equals 5 grams. Of course, we need to convert grams to kilograms. Okay, simply by dividing by 1000. Okay, by dividing by 1000. So we simply have 5 all over 1000, and that will simply give us as 0.005 in kilograms. Okay, so we have this next thing that was given. It says if the catapult is stretched through a distance of 7 centimeters, so that simply means the extension of the catapult rubber, extension E, okay, E equals 7 centimeters. And then again, you have to also convert 7 centimeters to meters simply by dividing 7 through by 100, and that simply gives us 0.07 in meters. Okay. Okay, so we have that if okay through a distance of 7 centimeters by an average force of 70 newtons. So force was given to us. The force applied F was given as 70 newtons. Okay. Question says calculate the instantaneous velocity of the stone when released. Alright, so we're looking for velocity V. Okay, so first of all, we were given a mass and we were given an extension. We were also given a force. So which means if we have an extension and we have a force, recall from Hooke's law that the force applied on any object is directly proportional to the extension of the object. So which means we are definitely going to apply the concept of Hooke's law here. But then again, before applying the concept of Hooke's law, since we're talking about a spring, because the catapult has a string, and therefore, if it stretches to release the stone, which means it has an energy, it is the energy that propelled or releases the stone, and that energy is simply called elastic potential energy. And from formula, we know that elastic potential energy is simply given as 1 all over 2 times the spring constant times extension all squared. So all we need to do now is to either find the spring constant or also recall that we can as well recall that force is actually equal to Ke from Hooke's law, that force is simply spring constant times extension. So we can simply make spring constant subject here. If you make K subject, you simply have it to be force all over extension. Okay, so simply dividing through by extension, that gives you the value of the spring constant. And if I substitute the value for the spring constant into the formula for elastic potential energy, I will simply have that potential energy is now equal to 1 all over 2 multiplying by, in place of the spring constant, we replace with simply force all over extension times extension squared. So notice now that extension can actually cancel one of these extensions. It now implies that the spring potential energy, okay, which is the elastic potential energy, is simply 1 all over 2 Fe. So this is another way to define the elastic potential energy. Alright, so we have the force and we have the extension. That means the elastic potential energy in the catapult rubber is simply 1 all over 2. The force is given as 70 newtons, so multiply by 70 multiplied by the extension. The extension is given as 0.07 in meters, 0.07. So if you multiply this through, we are going to simply have that the elastic potential energy is simply equal to, that will give us simply 24 joules. So this becomes the elastic potential energy in the catapult rubber. But then again, the rubber was released and the stone was projected. So when we release the rubber, the potential energy was actually converted into kinetic energy. Okay, when the rubber is released, the potential energy in the catapult rubber was actually converted into kinetic energy. And what is this kinetic energy? Kinetic energy is simply giving us 1 all over 2 times mass times velocity all squared. This is the formula for kinetic energy. So the potential energy in the rubber actually became the kinetic energy. It was transformed into kinetic energy when the stone was projected or released from the rubber. Okay, so for equilibrium to be achieved, the elastic potential energy must be equal to the kinetic energy of the stone. But then let's obtain what the kinetic energy is. Kinetic energy itself is now equal to half times the mass of the stone was given as 5 grams, which we converted to kilograms. I will obtain 0.005 kilograms. So simply multiply that 0.005 multiplied by velocity squared, which is unknown. So this actually means that the kinetic energy is now equal to, that gives us 0.0025 v squared. Alright, so I said for equilibrium to be achieved, the elastic potential energy must be equal to the kinetic energy in the stone. Okay, so we simply have potential energy to be equal to kinetic energy. And if we have this, we simply would equate these two values that we obtain for potential energy and kinetic energy. Okay. Alright, so the potential energy gave us 24 joules. Simply 24 is equal to the kinetic energy itself give us 0.0025 v squared. So we have 0.0025 v squared. So we can simply make v squared subject. This simply implies that v squared itself is now equal to dividing through by 0.0025. We simply have 24 all over 0.0025. Okay, v squared is now equal to, alright, so 24 divided 0.0025 gives us 9600. So to actually find v, simply take the square root of 9600. This implies that v becomes sorry, the square root of 9600, and therefore we can obtain the value of the velocity as simply square root of that value give us 97.98 meters per second. Okay, so this becomes the velocity of the stone. So that's how you're able to calculate the velocity. Simply what? First of all, obtain the elastic potential energy stored in the rubber, and then if the rubber is released, it converts the potential energy into kinetic energy. Then we can obtain the kinetic energy of the mass. Sorry. So notice now that it was the potential energy that was converted into kinetic energy. So which means the two energies are what? Equal. And if you do that, you obtain the value for the velocity. Alright guys, I hope you enjoyed this video and you find it interesting. Please, if you do, don't forget to keep your thoughts in the comment section. And I will see you in the next video with more questions on Hooke's law. Thanks.